So from the outside at least, it seems like you're not a real graphics programmer unless you've made a video or a blog post about grass. So let's get into it. I'm using tiles of grass. Each one has 81 blades of grass. You can see this one individual tile right here. I went with 81 mostly so that the circle doesn't have the large pixelated circle look. It kind of still does, but it's a little bit better than uh, some of the larger tiles that I attempted. Anyways, it runs at about 3.2 milliseconds on the GPU, and if I turn off grass, it runs at about, I think, 0.6. In most of my tests, the grass takes about 2.3 milliseconds to render. It's not very expensive, which was the main goal because my goal FPS is 144. So let's get into how the grass was made. First up here I have a few constants. Blade density is the space in between each grass. I had a goal value which was the appearance of St. Augustine grass, which is the native grass in Houston, or one of the native grasses. And I have a circle that is 17.56 meters in diameter, and I get my blade density from comparing my goal circle to my desired blade density. Right, so I have my right X, this is up here in a constant to make it easy to change. And then I have each blade is 3 vertices. I have the vertices here, where basically by default each blade only has an X value and a Y value. And then I have a few random generated numbers to create some variance. First, I randomize scale. Each blade can generate anywhere from half size to full size. And then I have 3 different randomized rotations. So a blade can lean forward or to the side, or it can turn. And then I also have a local random offset. This will cause variation in the space in between each individual blade, so that they're not all lined up like neat little farm crops. And then I have color variance. The shade will vary anywhere from 20% darker to 20% lighter. And then there's a 1 out of 20 chance for it to be a dead blade. When it is a dead blade, it can vary anywhere from the normal green to a yellow. And then after I've generated 81 blades, I will make a patch. And that's basically this right here. I just add the vertices to one big buffer, the indices to one big buffer. And then I am done with that patch, and I make 5 at a time. The program runs fairly fast. I think even when it wasn't multi-threaded, it finished in about 3 seconds. But I had no experience with multi-threading at the time of writing this program, so I multi-threaded it up just to get some experience with that. It runs fairly fast. It's almost instant. Then we have our shaders here, the position, the color. These are both vertex attributes. And then I have, for the instances, I have a transform, an instance, text coordinate. Basically, the entire patch feeds from the same texture position and the wind texture. Right, and so each blade is affected differently by the wind, or stronger by the wind, I guess, the higher it gets. So the base of the grass won't move at all, and then the tip position will move the most. And I do very little in the fragment shader to save time. I had experimented with a color texture for the grass instead of a vertex attribute, but it was much slower. I don't remember what the benchmark was, but basically when you're doing a square root on around 10 million fragments, I don't have the exact fragment count, but that's an estimation, it will take a decent amount of time. And that's pretty much it for that. I had done a few calculations when I was making the grass, mostly to find density area between each. I did a couple of benchmarks. One of the few key things I was looking for besides performance was the total data size. I found that when you lean towards one way or the other, say you have one blade of grass in each patch, and then you have, nearly a million patches or more, the data size gets quite large. It's about 47 megabytes. But if we skip down to 81 blades per patch, it is only 2.4 megabytes. And each individual blade or patch is like a few kilobytes in size. And if we get larger patches, the data usage on the GPU goes down a little bit even more. And then if the patches get too large, the instance count gets pretty low. Then the GPU size will blow up again. Right, and so one of the things I was searching for when I was first making this was what was the balance between instance count and base model size. And it seems like as long as you have some kind of balance, like not one base and then millions of instances, but instead say 100 in the base and 100,000 instances, then it balances out a lot better. Right, like here, like this one here, it has about 8,000 patches, and the performance is pretty much similar to this one that has 40,000 patches. It's a 0.2 millisecond difference. That could just be a testing error, it could be something else, I don't know. But basically the performance is similar enough that I just went with the smaller size so that the grass would have a little bit more detail. Like the wind pushing a smaller square instead of a very large square gives the impression of a little bit more detail. Anyways, if anybody from the Global Graphics Committee sees this video, I'm ready for my Certified Grass Programmer certificate. Graphics Programmer. I'll make a few more videos. I'll talk about a few other things in the engine in the next couple of days. I'll probably be talking about rollback netcode, my loading screen leaps, and not really sure what else. Maybe multi-threading or something. I don't know. Anyways, next couple of days. Keep your eye out for it. And the 8 Wins demo is live on Steam. I'll post a link in the chat, in the description.